And welcome back to Math Monday. Today we are going to be working on the Box and Whisker Plot, sometimes known as just the box plot, and the math that we're doing now is definitely getting spicier. On our hot pepper list, we are now up to habanero. This small orange pepper is well known for having Scoville heat ratings in the 100,000 to 350,000 range. Now that is quite a range, but this is getting to be a seriously hot pepper. For example, the other night I made dinner using a habanero, and I chose the very smallest one in the grocery store. And I cut the stem off, and I cut the seeds out, and then I cooked it for like 4 hours as part of a stew, and it still made the entire dish spicy. So this math is challenging, but like all things that are challenging, if you work on it, you can figure out how to do it, and you can be good at things even if they are hard. So, for a box and whisker plot, this is the way that we are going to organize some of the other landmarks that we have found and only find a couple of new ones. So, a box and whisker plot basically looks like this. It's got five vertical pieces, and then it has some connections going between them. The center three landmarks make a box, or in this case, it's a rectangle, and then the minimum and the maximum kind of come out to either side a little bit like whiskers. You may have a cat or a dog at home, and you might be able to kind of visualize this is the way their mouth would be, and this is the way their whiskers are. Now, unlike your friendly family pet, the whiskers on the box and whisker plot sometimes are not totally even, unlike the family dog. Anyway, we're going to get started here and jump right in and kind of learn as we go. So you will see up here, I have taken our data set from rocket flight number 1, and I have organized it from least to greatest. Now, that's not the first time you've seen that. You saw this a couple of weeks ago when we worked on median. It's the same technique because we're going to need median again, and additionally we're going to need quartile 1 and quartile 3, which are just medians. So our box and whisker plot is composed of 5 landmarks in data, and we already have 3 of them. The first one here is going to be the minimum, and that's really easy. We picked that out. It was the first thing we did, and it was 8. Our maximum, or the final vertical line, that we had also picked out long ago, and that was 14, our longest rocket flight. And the middle was our median. Now, we already calculated median, but we will review how to do so. Recall that the median is simply the center number in the data set when lined up from least to greatest. So, to review, you start at the bottom of your data set, and you kind of mentally cross out the bottom number, the top number, bottom, top, bottom, top, bottom, top, until you end up with either one number in the center or, as we have in this case, 2 numbers in the center. You will also recall that when there are 2 numbers in the center, you need to find the middle between those 2 numbers. Now, fortunately for me, my 2 middle numbers are the same. So the middle between 11 and 11 is simply an additional 11 up there. So that's going to be my median. I'll mark that here. My median. And that was 11. Finally, I'm going to need to find my first and third quartiles. Now, those are new words to you. Quartiles. You probably recognize most of that word from the word quarter, which would be a quarter of a dollar. So a quartile is actually going to be a quarter of the data set. And when we find our first quartile, sometimes known as Q1, we're finding the middle of just the bottom half of the data set. Now, conveniently, we have already broken our data set into a top and a bottom. We have the minimum to the median is the bottom, and the median to the maximum is the top. So to find the bottom quartile, or Q1, we're going to find the median of the bottom. Now, in order to do this, you're going to remove or discard the actual median that you used. So I'm just going to cross out this 11 right here. So now I'm finding the middle between these 5 numbers. If I cross out 8 and 11, that's my first bottom and top combination. The 9 and the 10 is my second, and this 10 is Q1, the median for the bottom half of the data. So I'm going to put Q1 here, and that happened to be 10 in this data set. Now, in order to find Q3, I need to do the same for the top. Again, I've removed my actual median, and then I will cross out the bottom, the top, the bottom, the top, and there 12 is the center or the median of the upper half of my data set, and therefore the 12 is my third quartile. So I'll put that here, Q3, and that happens to be 12. Now, I need to at this point redraw my box and whisker plot because it is not yet what we call to scale. I just can't draw a box and insert the numbers where it would be convenient if they go. I have to actually draw a number line with even intervals between each and every number, and then I plot my box and whisker plot over it. So the first thing I do is I draw my number line down here. And I know that my number line needs to go from at least 8 to at least 14. So I might, for the purposes of clarity for anyone watching, go ahead and back it off a number and increase it a number at the other end. So my scale is actually going to be 7 to 15. 7, 8, 9, 10, 11, 12, 13, 14, 15. Notice how I have the same distance between each number. Whenever you're drawing a straight line on your math paper, it is a good idea to use a straight edge. So that's what I'm going to do. And I'm using the edge of this marker box. Just because you don't happen to have a ruler with you doesn't mean you can't get a straight line. Lots of objects can be used as a straight edge, the edge of an additional pencil, the edge of this box of markers, the edge of your silent reading book. There are lots of good choices. So now I'm going to plot my landmarks for my box and whisker plot as my vertical lines right above my number line, and then connect to make my actual boxes and whiskers. So my minimum was 8. I draw a vertical line there. Q1 was 10, another vertical line. My median was 11. Q3 was 12, and my maximum was 14. So I have my 5 vertical lines now representing the 5 landmarks in data. Minimum, quartile 1, median, quartile 3, maximum. You may have noticed that some of my landmarks start with the letter M and some of them start with the letter Q. There's a handy way you can remember this. There are 5 landmarks and it goes M, Q, M, Q, M. Conveniently, you have 5 fingers unless you had an unfortunate incident involving an alligator, and then you may have less. In that case, box and whisker plot may not be your biggest issue. Anyway, now that I have my vertical lines drawn, I can go ahead and connect the middle 3 into the box, and then my minimum is connected to Q1, and Q3 is connected to my maximum, and now I have a to-scale box and whisker plot. A box and whisker plot like this allows you to see tendencies in the data. If I had a minimum that was very, very small, I would have a very, very long whisker here, indicating that that was perhaps an outlier in my data. The same can be said as far as the maximum goes. A maximum that's very, very close to my box might let me know that my data is fairly homogeneous or similar, whereas a maximum that's really far away might let me know that my data is a lot more spread out. The size of the box here in the middle lets me know, again, how homogeneous or similar the data is. A very, very small box in here would let me know that my data is very, very close together, whereas a very long extended box would let me know that my data set is much more variable. Now, as I've said many times before, you would have to practice this multiple times in order to get Box and Whisker Plot, some seriously spicy math, to be solid and part of your regular math repertoire. Also, there's a lot more that could be said about Box and Whisker Plots that we don't have time for in a video such as this. So if this math is interesting to you, you could give this a go, and I'm certain that there are other resources available so you can continue your study of this kind of statistics. Bye for now.